Hey everybody, my name is Beau Fish, and this is going to be the first video to my Precision Instrument Approach lesson. Now we'll talk about what a Precision Instrument Approach is, and by example from the AIM, it gives us three different approaches. It'd be a PAR, a GLS, or ILS. PAR and GLS are not super common, you're not going to see them everywhere, but the ILS you will, and that's what we're going to concentrate in this lesson. And so what a PAR is the controller is going to give you, it's basically talking you through the approach. They're going to give you corrections, and you're going to fly those corrections based on what they tell you. GLS is going to be GPS based, but it has ground reference stations. They send a correction signal to the aircraft, so it does incorporate a ground based correction signal, making it a precision instrument approach. And then we have our ILS, Instrument Landing System. And the reason this is important is, let's say we're flying IFR in the clouds. You call, for this example, we'll tune up the weather at St. Pete Clearwater Airport on 134.5. We get the weather, it says it's calling 250 feet ceilings and 1.5 miles visibility. Now there's no way we're going to be able to land at that airport unless we use a precision instrument approach. Now there's no PAR or GLS here, so we're going to utilize the ILS, Instrument Landing System. And I have the instrument approach chart pulled up here, and you're going to see that there's a lot of information on this instrument approach chart, but what makes it a precision approach is that it has glide slope and a localizer. The glide slope is going to give you the vertical guidance, and the localizer is going to give you horizontal guidance. And this is all ground based. The ILS itself consists of three parts. So you're going to have your guidance information, your range information, and your visual information. Your guidance information is going to be your glide slope localizer. Your range information is some form of distance, so it might be DME, outer marker, something of that sort. And then you have visual information, which is the instrument approach lighting system. Those are the three parts of the ILS, and we'll go over where all those parts are and how all of it works together to get us down below minimums safely by flying the approach. When we're looking at the instrument approach itself, it provides a method to descend and land safely in low visibility conditions. And this first part of this lesson, we'll start off with the pilot briefing section at the very top, and then we'll work our way down in later videos. So the top pilot briefing section consists of, in the top right, you have the approach name and the airport name. So you have the ILS or localizer runway 36, and we have St. Pete Clearwater International with the identifier PIE. Now, the reason that's important is, let's say we're doing a long cross country or going to an unfamiliar airport, and it has a lot of instrument approaches available now, or parallel runways. It can be really easy to mix up which approach chart you're looking at versus what ATC thinks that you're flying or assigns you. So we'll just need to verify that we're on the correct runway, we're shooting the ILS, and that we're at the right airport. And we're going to have backups for all of this, right? So every time we tune a navigational aid, we're going to identify it. That way we know that we have tuned to the exact navigation aid that we have on our chart. And then, so talking about that, in the top left corner, we have localizer DME 108.7 is the frequency. So the top left corner is going to give you the navigation frequency that's used for this approach. In this case, it's the localizer for runway 36. And then one step over, we have the final approach course of 356, and then we have our runway landing information. 8,720 feet is available for landing, and our touchdown zone elevation is 10 feet, airport elevation is 11. And it's very important that we make sure that we can land in the runway available for the airport we're going to. And the touchdown zone elevation gives you a good idea in relation to our minimums, which we'll talk about a little bit later. Over here on the right, below the airport name, we have missed approach textual description, and you're going to see the missed approach procedure several different ways on this instrument approach chart. This one is the textual, so you can just read it because it's in the pilot briefing section, and sometimes that's easier to brief it from this section. So missed approach, we're going to climb to 600 feet, then climbing a left turn to 2,000 feet on the Pi Vortac radial 276 to the fall intersection at 8 DME from Pi and hold. And then we have our notes section here. I'll touch on that in just a little bit. And I'll drop down here to our communications area. So it's in the order you're going to use it. So you have ATIS with 134.5. We're going to tune that. We're going to get the weather at the airport. We're going to be talking to Tampa approach on 125.3. And then when we are shooting this approach, they're going to eventually switch us over to tower. So we have 118.3 is the St. Pete tower. And then once we land, we're going to have 121.9 is going to be ground control. And then we also have our clearance delivery and Unicom if we need them. Alright, in this notes section, you're going to have important information. And there's going to be things in here that might change the minimums, or they might make something not available or not allowed based on outages of weather stations or something like that. So we always got to read the notes section. This one says DME or radar required. So that's important. If we don't have DME, we're probably not shooting this ILS unless we have another means of distance measuring equipment like GPS approved, stuff like that. Or in all else, we could have radar required, meaning the controller's radar has to be functional and they can identify these points for us if we absolutely had to. Now below it, I picked this one because it does not have a lot of notes in it, but it does emphasize this trouble T, which we call it. It's the black triangle with the white T in it, and also the black triangle with the white A in it. And I want to take a few minutes and show you that there's other publications you got to go to for this information. So the black triangle with the white T, it means that there's non-standard IFR takeoff minimums. For Part 91, we don't have to comply with that, but it's not safe. So it's always a good idea to look at those and probably just comply with whatever commercial operators are using, or increase a margin of safety above that. Just because we can do something doesn't mean we should. So I'll show you real quick in takeoff minimums. This is another document you need to look at in order to find those. We have St. Pete, Florida, and we find the airport we're going to. So we have PIE here, runway 36. It's saying that there's obstacles beginning at the departure end of the runway, and we need to basically make sure that we can clear these obstacles. And that would be great to know whether we're Part 91 or not. And we need to make sure we incorporate that into our IFR departure. Make sure we have enough clearance. And there's another document here with alternate minimums. So if we were going to file this airport as an alternate, we would have to comply with this document. Everybody has to. So St. Pete, Clearwater, Florida, PIE, runway 36, and we have a couple of notes here. So it's not allowed or not authorized when the control tower is closed. So we can't file this one as an alternate if the tower is closed. And then it has 3 there. So ILS categories A through D is 702. So it has a different set of weather minimums to file this as an alternate if an alternate is required. And that sums up the pilot briefing section, and then we'll continue to go through other sections of this instrument approach chart in later lessons. Thanks for watching.